So just have a look on this slide here right now. Okay. Okay, so before we start with the slides for today's chapter with first class of us, okay. Some of the chapters Miss will be bring up earlier, okay. So maybe based on the sequence number, I not really followed, okay, because Miss want to relate it the topic each other. Sometimes we need to do parallel, okay. So that's the reason I make it some topics parallel or Miss teach the chapter 5 or chapter 6 earlier before we go on with the chapter 3 example. So we need to know a few things before we start with the next topic. Okay. So have a look at this part. This is based on the electrical quantity. Okay. So what they mean with the electrical quantity? So maybe some will say based on the quantity is based on the amount. Means okay, yep, it's based on the amount. But beside the quantity, we also need to know based on the scientific value. Okay. So let's go with the next slides here. All right. Okay. So when you have a look on this circuit, okay, like introductions. So in these introductions, you may have a look. They shows you in terms of the figure. You have a source. Okay, defined. Okay, just have a look on this part here. Okay, this is your figure. Okay. So where they shows you have the battery. So battery which is stand for the source. All right. Since these battery are connected to the switch. Okay. This switch we call as a electronic components. Okay. And this the part are connected, and after that you can see it's connected to the light or the connected to the lamp here. Okay. After that you can see they shows you in terms of the connections here. Going back to the battery source. So when you see, even though when you see your battery, a normal battery, we always call as a source. Okay, we have a polarity. So when I say polarity means where we have the positive polarity, we have the negative polarity. So what I mean with the positive polarity means have a look on the battery. Okay, have a look on the image here based on the battery here. So this shows you in terms of the plus. Okay, so this plus we call as a polarity. Okay, and this is a positive, not plus. We use positive polarity. At the same time, you may have a look on the negative. Okay, so this is the one thing. So when you make a connections, either you want to build up other circuit, okay? It's a simple circuit based on the diode, based on the resistor, okay? You always need to have a look on the source, okay? This means we need to have the connection from the positive going to the negative, okay? In terms of the loop, okay? Example, I show you this source. I converted in terms into a symbols of the battery, okay? Maybe some of you already know. Okay, this is the concept, the symbols of battery. We have the positive with the negative. So we have example, I have a diode. Okay, diode means is one of the components, electric components, and then I have a resistor. Okay, resistor also is a component. So it's connected. So from here, you can identify it means a simple or basic circuit. We always should have the positive polarity connected to the components. At the ending is connected to the negative. So it's where we have a loop. This shows in terms of the loop connections. It's again same goes to this diagram right now. You may have a look. Actually, it's connected in terms of the loop. From the positive, it going to the negative. But between the source, you have the components. Okay, and based on that point, okay, just have a look on the slides point given to you. The battery is referred as a source and the lamp is referred to the load. Okay, remember. Okay, beside the light, okay, beside other components, they also will replace it as a resistor. Okay, resistor also is a component where we call as a load. Okay, so this load, we're going to define it with you based on the current flow, based on the voltage flow. Okay, later on you will know what is it they mean with the current flow, what they mean with the voltage drop. Okay, so this is a basic circuit. So example, Miss asks you to draw. Okay, I ask you to sketch. Okay, example, I draw and sketch is the same thing. So when I ask you to sketch a simple circuit, okay, so our basic circuit. So you need to know your components always. Okay, the things that you need to be have in your circuit. Example, your source. It means your battery can be AC or can be DC. Okay, later on you will understand what is it AC and DC. And you will have a components, electronic components. Okay, so that's the one we call as a circuit. Sometimes they also call as a schematic. Okay, but usually we use the word circuit. This word, circuit. Okay, they also can circuit. They also can say a circuit diagram. They also can say it as a schematic. Okay, so just take note about this part here. Okay, let's go with the next part here. Okay, this is just what Miss explained to you in the first day based on the learning outcomes. Okay, so this is our first learning outcome based on the interpret the basic concept in the electric circuit. Okay, how is it works, right? So the next slide is based on the the keywords. Okay, we say as some keywords here. Not necessary will point out for your exam. Okay, so it can be in your quizzes. Okay, so the term they usually they use in this slide, or the word they always use for this topic. Okay, we call as a circuit diagram. We have electric current, we have a voltage, and take note. Okay, when they say voltage, this voltage also can represent, or they also can stated as a potential differences. Take note, because later on when you start to do a tutorial, okay, even though some discussions, okay, they're not going to highlight it to you a voltage. Okay, they will say it's a potential differences. So when they highlighted the word potential differences, you need to know that it stands for voltage. Okay, take note, potential differences. Either they can say EMF. So but EMF is not potential differences. That is different thing. Motive force. Okay. So later on you will know it. Okay, but this is the one Miss want to highlight it to you in earlier. Voltage, beside the word voltage, they also use the potential differences. Sometimes they only highlighted to you P dot D. Take note, they're not going to write for you a full term here, but they just highlighted to you P dot D. Okay, so once you read the questions, or once we do a tutorial together, okay, so when they highlighted for you PD, you need to know it stands for your voltage. Okay, and the next one is resistance. Okay, resistance, if you see, we also can say as a resistant, we also can say as a resistor. We also say as a resistivity. So they have a few things, but everything come on, we can assume, not assume, we will define it as a resistor. Okay, so resistor means the unit we measure is based on the ohm. Okay, why we need to have a resistor in the components. All right, the next one based on the circuit element. So circuit elements means sometimes the components, okay, the word I mean say components means can represent as a diode, capacitor, or the component. Sometimes they also say the word element. Okay, so elements means can stand for your component also. Okay, and the next one is based on the Ohm's law. I think not every not me say some, maybe everyone know what they say stand for the Ohm's law. So Ohm's law it means we can say as a equations, or we also can say as a formula. Okay, so this is related to the concept or the technique how you apply the Ohm's law. Okay, let's go for the next part here. Okay, and the next one we have electrical power. Okay, so when I say electrical power, we need to know how to calculate. Okay, so most of the thing you need to know the formulas and how you relate the formulas into your calculations. How you do your maths. Okay, example, you have a algebra, quadratic algebra to calculate, right, based on your maths equation, something. It's the same thing for this part. Okay, in the electrical uh, quantity, we also have some calculations. Okay, so we need to know how to use the formula. Okay, and the next one, okay, let's go. This is the one, the short terms that you always can find. Maybe you can find in your quiz later on. Okay. And the next one is based on the scientific and also engineering notations. So what they mean with scientific? Okay. Sometimes when we calculate, we can have a large number. Okay. I mean, the value we get a large number. Sometimes we also can get a value with the smallest number, more smallest numbers. Okay. So in terms of that, we need to know, or we need to remember. Okay, Miss always asks you, better for you to remember the scientific value. Okay, unless you can't remember, if you can't remember. Just give me 1 minute. Okay, before that, I just want to let you know, make sure you have a calculator. Okay, for our EEP, most of the thing we will use a calculator to calculate your value, and sometimes when you do your calculation, I always ask you to convert in a scientific value. Okay, so that's the time you need to use the calculator, but not necessarily you must have this brand. Okay, it's maybe you have different brand. Okay, maybe now you have the latest calculator. It's up to you. But just Miss want to stress here, when you see the calculator, okay, I hope you can see. Okay, so when you see the calculator on top of the number, this is where the model is 570. Okay, I hope you're using this one 570, because when you're using 570, you can find all the value, the scientific value is in unit here. Okay, so in terms of unit, you may have a look. Okay, example, I hope you can see. Um, based on the number 7 here. Okay, so you can see number 8, you can see number 9, number 4. Okay, of course you ask me, so I can see all the numbers here. Yes, I also know. But on top of number 7, on top of number 8, number 9, number 4, number 5, you can see a small letter here. They wrote, okay, they have type. There was stated here, which is M. They stated as a G. They also stated as a T. They also stated as a micro in terms of the U. They also stated a small m, small k, okay, and so on. Okay, so on top of the numbers, you can see they stated in the yellow, okay, yellow color alphabet. They stated M, they stated K, they stated in terms of U, micro, and also N. Okay, on top on number 3. Okay, I hope you can see that. Okay, it's better for you to have this one. Okay, let's see. Okay, so based on this part, you may have a look. This shows you in terms of a table form. Okay, so in terms this one, just have a look on this slide. Okay. Okay, so you can see the multiple. You can see they call as a prefix. Same time, you can see they wrote as a symbol. Excuse me. Okay, and before we go more deeper based on this table, just have a look at the side here. Okay, a scientific notations. Okay, scientific notations means they point out based on the symbols or based on your multiple. Okay, so in terms of this one, just have a look here. They wrote for you 2.47 times 10 power of 5 in a scientific notation. And the same things they wrote here 24.7 times 10 power of 4. Okay, it's not a scientific notation. And why they highlighted that here? Okay, because most of the value when you convert it after your calculation, we should keep in the symbols which we call as a scientific value. Now scientific value we say a scientific symbol. Okay, so now you have a look on the table, this table, multiple table. So I just go on the famous one, the one we always go through. Okay, we always see. Okay, so I just have a look on the 10 power of 12, 10 power over 9, 10 power over 6. Okay, at the same time, just have a look on the 10 minus 2, 10 minus 3, 10 minus 6, 10 minus 9. Okay, now you have a look on the prefix here. So example, when they highlighted to you 10 power of 12, it means it's tera. Power of 9, it means it's giga. Okay, power of 6, it means 10 for mega. So when it's go to your minus, okay, from the positive, they will always start with the positive, then we go on with the negative. Remember, when it's come to negative means your number is very smaller number. Okay, it's more smaller than 0. Take note, when they highlighted your power minus 2 or minus 3, you need to know is lesser than 0. Okay, it means more smaller than 0. Okay, so from here you may have a look a power. Okay, this is a power tera and this is a symbol. Okay, so when you do a calculation, you will have your answers. Example, this shows you in terms of okay, 3.75 times 10 power of 6. Okay, example, Miss just write this one here. Okay, so when I ask you to convert in a scientific value, okay, example, this one stands for ampere current. Okay, so when I ask you to convert in a scientific, you need to know this minus 6 stand for what. Prefix it is the stand for what. So example, minus 6 means should be micro. So the symbols of the micro, they're going to highlight it in the U form. Okay, so it's not U, but it looks like a U. Okay, so it means you're going to write 3.75 times 10 microampere. Okay, even though some will ask me, is it okay for me to leave it my answers in this format? Okay, of course can. Your answer is still right. But when you learn based on this part, okay, based on the symbol of scientific, engineering, everything. So it's better for you to convert in the micro, in the symbols of a multiple, we call as a scientific unit. Okay, so that's the thing that you need to know. Yeah, so take note, from the power of 18 to power of minus 18, you have the prefix. Okay,
Yes.
just take note of what, yeah.
Miss, for the second one, right, 3.75, isn't it just 3.75 microampere? Do we have to put times 10?
Times 10, where is it?
The
For the second one, miss, the micro there.
Okay, micro. Oh, you
is it?
mean the one I wrote?
Yeah,
Yeah,
yeah.
Oh, yes,
yeah,
yes. Don't need. Yes, this one don't need. So it means 3.75 microampere. Thanks. Okay. So you don't need to write power, multiple 10 power or minus 6 or just this one 10. Don't need, miss typo. Okay, miss write wrongly. Okay, thanks for that. So it means will be 3.75 microampere. Okay. So that's the one that you need to take note based on your multiple, based on your prefix, and also based on the symbol. Okay. So most of the thing I will ask you to remember. It's better for you to remember. Okay, so because sometimes you need to convert your unit later on. Okay, So the most common, you just have a look this one. The most popular, centi, milli, micro, nano, even we have pico. So when you come to your chapter of capacitance, maybe you will have a look. You will see the pico, will see the nano. Okay. So hope so. You just take note about this part. Those have your those have notes with you. You just write down based on the prefix and based on the symbols here. Okay. Maybe some of you already know about this one. Huh? Okay, so let's go for the next slide here. Okay, just have a look. Okay, example, Miss said is I give you one more units here. So it means 5.885. Okay, times with 10 minus 3. Okay, so it means when you convert, what you get? Can anyone let me know?
5.85 milli.
Yes,
Ampere.
milli. So milli, example, I said this is a volt. So it means millivolt. Okay, quite simple, right? Okay, so let's go with the next part here. Okay, okay, the next one is based on a circuit diagram. Okay, so let's say this is the one we call as circuit diagram. Take note, sometimes they just highlighted to you circuit, sometimes they call a schematic, sometimes they also highlighted to you a circuit diagram. So when they say circuit diagram, you may have a look. This is the one we have just now in the earlier where they shows you have the a battery, okay, and they also have based on the switch, but just now we have based on the light lamp, okay, but now we have based on the resistance. So that's the thing, take note now. Sometimes they call as resistance, sometimes they call as a resistor, the same thing actually. Okay, so this is a basic diagram that we have here. All right, okay, let's go with the next one. Okay, now have a look on the image here, the diagram here. Okay, just have a look because later on, um, those going with the simulations lab, okay, you need to understand a few not formula, a few symbols here that you need to know. Okay, so just have a look on your pictures here or the image here on your slide. Okay, so I just going to write first, second, third based on the sequence here. Number 1, number 2, number 3, number 4, number 5. Okay, so just have a look on the number 1. So in the number 1, if you see, this shows to you a conductor, but it's only a straight line, okay, but they stated as a conductor. Okay, and why is it they stated as a conductor? So when you draw a diagram, okay, example, let's go up here back, the basic one. So this line we call as a conductor. Okay, sometimes they use the word wire, okay, to present the conductor. Okay, why they say conductor? It means they allowed a current flow through, okay, and on this material. So that's the thing they said as a conductor. So we have a conductor, we have an insulator, we have a semiconductor. So take note, conductor means they are allowed the current flow, okay, on the materials. Okay, in basic insulator, so insulator, we cannot conduct a current, okay, even same time we cannot have a current flow on the material. So that's why we call as insulator. Insulator means more to hood type, okay, like a pencil, okay, like a table, okay, that's the one we call as insulator. Semiconductor means is where we say 50% conductor, 50% insulator. Okay, that's the one they call as a semiconductor. Okay, so just take note about this one based on the line here. Okay, why we showing based on the straight line here? Okay, so this line where stand as a wire. Okay, take note beside wire they also use the word jumper. By jumper when you want to show a connections to one more component to one more component, okay, but most common thing we say wire. Okay, so straight line, that's the thing we call as a conductor. Okay, now you move to the second part, the second column here, this one, the second column. So in the second column they shows you like a two line overlap. Okay, you can see this line, okay, I put line A, this one line B, sounds like an overlap. Okay, but what they let you know, the two conductors are crossing but not jointed. Okay, what they mean? It means they are not connected. Okay, so when you have this line, when you draw, because later on you need to sketch, you need to draw. Okay, so when you draw maybe some of the resistor or capacitor, you need to have the you need to make a cross. Okay, but this line when you're doing a cross line, but it's not connected with the components. Okay, so example, I just let you know, this one I have resistor, okay, and this one I have a capacitor. Example, just assume a components, electronic components, okay, this is electronic components, this is electronic components, then it's connected to the next electronic components. Okay, Okay, this is an inductor, like one of the electric components, then is connected to your source, example AC source. Okay, so it means this line actually is not connected. Okay, it means this line is not connected to this line. Okay, but it just shows you like an overlap. Okay, so when you can identify when you try to use the tools, I mean the software. Okay, so that's the thing that you need to take note. And the next one, have a look on the third column. In the third column, when you draw, okay, usually sometimes students, when they draw manually, they forget about the dot. They won't show that it's connected. I miss, can hear your voice. Is it someone want to ask anything? Mm.
Kai Feng, you are not muted.
Mm. Okay, Miss, continue. Okay, so the next one, sorry, this dot, okay, it means you are connected. So it means when you are connected, this line, okay, example, you have this resistance, then you have a capacitor. So it means this flow, okay, I mean the current flow of this one, a current flow of this one are connected. Okay, so they can be divided or splitted the current. Okay, so this the one that shows you in terms of interconnection. Okay, it means it's connected. You may use the word connect. Okay, connected, or the word connect. Okay, so join means you can use the word join, but more suitable means we'll say when he's come to your wire or he's come to your conductor, use the word connected. Okay, is connected. So this dot, okay, when it's a common thing when we ask a student to draw, okay, our sketch, they forget about the dot when I ask them to show the connections between the two components. Okay, so but when you using a software, it's automatically they will shows you a dot. It will come out when it shows when you start to draw. Okay, so just take note about this part. Okay, and the next one is based on the resistor. So when I say resistor, this is the one resistor. Okay, we also have one more a separate chapter based on your resistor. Okay, but that one later on. So when they say resistor is like one of the components. Okay, and this component they shows you in terms of the square type. This one. Okay. At the same time, they shows you in terms of the symbol. Okay, so this symbol represent as a resistor. It means they look like this. Just now, if you realize, if you go back to the previous slides, okay, they also use the word resistant. It's the same thing, this one, okay? And then have a look on the third column here. So in the third column, okay, it's the same thing what they shows you in the first column here, but they have something different based on the variable resistance. So variable resistance is where you can arrange, not arrange, you can adjust the value of the resistor. Okay, so it means, okay, example, okay, uh, let me show you the example first before I go on with the next flow here. Just behold, okay, let me show you the example of resistor so you may have some idea. Okay. Okay, so okay, so example, this is a resistor. Okay, we call as a resistor, we call as a resistant. This is the one, how does it look like? Okay, later on I will teach you based on the how to identify the measurements of the value of the resistor based on the code or based on the color bar here. Okay, so these are how does it look like based on the resistor. Okay, and what they mean with the resistor variable. Okay, they always have three terminals. Mm. Okay, so I just okay, let me pick up this one. Okay, have a look. This is a variable resistor. So variable resistor, the one which shows you the normal one resistor, they always let you know, okay, that is 37 kilo ohm. Okay, could be 50 kilo ohm, or they specific for you 100 kilo ohm. But when it's come to the variable resistor, they always have in terms of the range. Example, they will say 50 kilo ohm to 100 kilo ohm. Okay, so between the range, so you can set, you can adjust, okay, the toggle on top here, okay, to get the accurate measurements value. So that's the time we call, we need to have a variable resistor. So when variable resistor, you have three terminal. Okay, when it's normal resistor, you only have two terminal. It means two terminal means two link. Okay, I always use the word link, but the proper one we use as a terminal. This one. So it means we have a terminal this side, okay, and we have one more terminal at this side. Okay, this is the one I call as a terminal. Okay, so that's the one Miss want to show. Okay, let's go for our slide here. Okay, so that's the one is a variable resistor. Okay, so have a look number 3. So in the number 3, okay, number 3 they also call as a cell. Okay, this one not cell molecule. This is a cell where we say it as a battery. Excuse me. So they can sketch or they can draw in terms of you have 3 cells. So one cell represent this one. Sometimes they highlighted to you the voltage 1.5. Usually for your battery, I can't remember. Triple A, I think triple A or double A, they always highlighted to you the battery. Okay, so in terms of battery, they put for 1.5 volt. Okay, it depends on the battery. Yeah, same goes to this one. They shows you in terms of you have 3. Okay, so it means you have 3 battery source. Okay, so that's the one they shows to you in this way. Okay, and the next one they shows you alternative symbols of the battery. So it means when they put a dash at the middle, it means they can have a multiple battery. Okay, so that's the thing they shows you in terms of alternative symbol. Okay, and the next one will be in terms of the switch. Okay, switch means always they shows you in terms of this one. Okay, it means it's join means it's open. This sorry, the switch is on. This one, okay, example, the switch is like this straight line connected. We say the switch is on. Okay, and the same time you may have a look on flaming lamp. Okay, this based on the lamp symbols here, and next one based on the fuse. Okay, fuse. We not much cover up based on the fuse, but when you open your plug, I misconnect. Okay, plug. Okay, your handphone charge. Okay, example in the plug, any plug you can find the fuse. Okay, but this one, we're not going to cover much on this part here, but that's one of the components, electronic components. And the next one, they shows you based on an ammeter, voltmeter. Okay, what we can see in the ammeter with the voltmeter. These two part, we also can find in a multimeter. Okay, so what they mean with the multimeter? So, okay, this is the shortcut way I always want to show something. I always Google here, so you may have a look this part here. Okay, multimeter. Okay, you have a look on. Usually we have this type in the lab. Okay, let's go with a. Let's pick up one. Okay, example this one. Okay, just have a look. Okay, in this multimeter, okay, we always use to measure your value either in a voltmeter or in ampere. Even we can measure the resistor ohm. Okay, so when you see the multimeter, okay, when the two probe, okay, I call this is a probe. So they always have the positive probe, they always have the negative probe. Okay, so this how we set. Okay, how to measure. Even we have the ohm measurements. Okay, how to measure. You put your resistor, you measure positive, negative, they will show you how much the value of the resistor. Okay, beside you calculate manually. Okay, so this is the one we call as a multimeter. So the one we have in your slide, okay, this is the one that shows you in terms of symbol. Okay, this one, okay, this one, 2, 3, 4, 5, okay, in terms of symbol, ammeter, voltmeter. So when we have in your schematic based on your circuit, okay, example, this is I have the source battery. Okay, then I have a resistor, example resistor. Then I have inductor. Okay, then I connected. I always need to have a ground. Okay, so when I put this symbol ammeter or either I put a voltmeter, okay, example misdraw here, okay, A. So it means you need to measure a value at resistor. Before the resistor, how much is the ammeter? It means the current flow is how much. Example, I put this one, okay, V, the symbols of V. So it means voltmeter. So I need to measure how much the voltage, okay, after the resistor. So sometimes we have the voltage drop at the element. It means at the components here. We call it as a voltage drop. So this symbol you will find later on when you have a circuit, okay, based on your circuit diagram, DC circuit. Okay, so this is the symbol they always use to measure your current, to measure your voltage. And the next one is based on the fuse. This is the alternative symbol. Okay, the symbols of the fuse, how does it look like? Okay, so this is the most common um, common popular and always you need to know. Okay, circuit diagram, please take note. You must know. All right, So let's go with the next part here. Okay, and the next part is the basic atomic structure. Okay, this also makes sure I think everyone know about this one. So when they say basic atomic structure, you can see they shows you in terms of the orbit. Okay, in terms of the line. Okay, they also have electrons. Okay, you may have a look on this part. Okay, in the blue circles here. Okay, and you also have a look on the positive, the red circle here. Okay, and just have a look on the neutron. Okay, it means at the middle point here. Okay, so usually at the middle point we have a neutron. Okay, we call as uncharged, and at the same time at the electrons. Okay, this blue circles here we call as an electron. Take note, electrons also represent as a negative charge. Okay, and at the same time they shows you in terms of the plus. Okay, so it's where they shows you in terms of the positive and where we call as a proton. Okay, and why we need to have a electron, why we need to have a proton. Okay, this structure, okay, no matter any structure, okay, based on the material, we always have this electron, we always have proton, we always have a neutron. Okay, what I mean with the material, so this material is based on a semiconductor. Okay, in a semiconductor. Okay, what they mean with the semiconductor, so semiconductor example, silicon. Okay, you can find germanium. So okay, it's not sure. Okay, I hope you know what is periodic table here. They have a periodic table. Let me show you before we go more deeper. Okay, let's have a look this one. Okay. All right. Okay. Later you can try to Google. Okay. So this is where we call as a periodic table. So each of the periodic table, I mean, they have in a group. So when it's come in the group, okay, they have silicon, they have germanium, they have arsenate, even gas. Okay. So in terms of that, they was write on top here the number. Okay. They shows you 5. They wrote you 13. They wrote for you 14. So these numbers actually represents the one we have in our slides here. This one. Okay. Take note. This is the one. That's why some of the material we call as a semiconductor. How is it works based on the electrons and the protons? How is it works based on the orbit? Okay, the line, that circle line, usually we call as a orbit. This line, okay, the circle one. Okay, and where we have the valence based on the valence equivalence bounded. Okay, everything will be covered up based on this basic atomic. But for today class, we just go basically what is it they mean with the atomic structure here. Okay, so why we need to have an electron, why we need to have a electron and protons here, because usually electron and proton is where we call as a molecule. Okay, we can't see with our eyes. Okay, but it's always in the, onto a materials. Okay, so that's the things we need to know, and they have the band gap. Okay, how they move the electrons, how they move the protons here. Okay, right. Okay, let's see. Okay, before that, just have a look. This is the one we call as a charge. So when I say charge, is where represent based on your protons. Maybe some of you a bit blur. Okay, what means it proton, electron. So the maybe hope so for the next part. When we go through with the other topic, you will understand what I mean with the electron, what I mean with the protons here. Okay, it actually is covered up based on your semiconductor. Okay, let's see based on this part here, charge in electrical properties of the atomic, okay, or we call as a subatomic particle in a matter of consistent measurements of a column. Okay, when they say charge, okay, it means charge we can't see by our eyes, but it can represent as an electron, it can represent as a proton, but we call as a charge. And this charge, okay, example I put as a cube. Okay, the unit we always not the unit we always specify the charge in terms of the cube. And this unit, how we measure is based on the C. Okay, this means the molecule, that's the one we call as a charge here. Okay, so and the unit is a C. Take note about this one. The unit that we measure is a column, it is C. Okay, at the same time, have a look on the next part here. Electrons, they say electron. Okay, some book, okay, not book, some of the internet source, okay, they only highlighted to you E minus. Every time they specific for you a E minus, take note is represent based on the electron, and this electron where we call as a negative ion. Okay, when it's a proton, or they say as a positive, is a represent as positive ion. Proton, positive ion. When they say electron, it means it's a negative ion, and each of the electron they have the subcharge. Okay, so we call as a atomic. Okay, in terms of that, there is specific value, or we say as a constant value for your electrons. Okay, just have a look on this unit. Okay, so they already specific for you how much the electrons will be carried, or the charge value. Okay, so the most of the thing they already specific for you. One column is means the charge, one column equal to how much is it the charge. So this is the one that you need to remember. It's better for you take note about this value here. Okay, so normally electron charge they say 1.6, but when they counted based on the column or based on the unit, it represents 6.24 times 10 power of 18. Okay, based on the negative electron. This is the unit that you need to know. Okay, sometimes when you do a calculation, this value not given to you, so you need to remember indirectly, you need to know. Okay, so just take note about this part here. Okay. All right. Okay, so okay, let's go for the next part here. The next part is based on the electrical current. How, what is it, the current? Okay, back to the, let's see, let me start on the slide. Okay. Based on your circuit, lamp circuit, they have E electrons flow in the loop. Okay, so what they mean with the electrons, from the negative terminals, they're going to the positive terminals. Okay, other than that, okay, we also have the opposite way. Okay, flow of the charge, positive charge from the negative positive terminal. This positive, sometimes they use this one, a positive VE means is a positive. Okay, sometimes they're using the minus with the VE means it's a negative terminal. So when you have a look on your schematic in your basic circuit, let's see whether we have here now. Okay, so you can see each of, okay, example, this the one we say as a wire, right? So in the wire, we only can see the copper. We only can see the copper, but we can't see the electrons move. So what they say here, when you have the atom based on the electrons, okay, they start to move when you have the supply. When you don't have the supply, when you don't have the source, the electron not going to move. Okay, not going to conduct a current flow. Okay, this is the one we say the currents flow into your circuit. Okay, and at the same time we also say voltage drop at the terminal. Okay, so this is the one they shows you in terms of the particular we call as atom. Okay, which represent the charge. Okay, at the same time we say as a current flow. All right, so that's the one you need to know. Okay, we can't see, but we only can see, even when you open your cable inside, you only can see a copper. Okay. Okay, so let's go. Okay, have a look on the next part here. This is based on the unit, how you calculate the unit, how you calculate your current, how you calculate your charge. Okay, at the same time, they specific for you a 4. I think they have a 4. Okay, just have a look at these slides here. Okay, based on the rate of the current flow, or based on the calculations. Okay, we call as SI. Okay, so SI unit based on the ampere. Remember your current, means put current. Current is always we measure with the ampere. Okay, and the unit or the symbol we use as a. And how to get this value, current flow, is based on your circuit. Excuse me, based on the circuit. Okay, now you have a look on the formula. They have 4 formula. They are not 4 formula. Actually, they have 1 formula, but they just specific for you. Q stand for what, I stand for what, T stand for what. Okay, this one they shows you in terms of the current, how they calculate. Okay, this shows you in terms of the dq divided by dt. Okay, in your integration, but we're not going to do that. But in terms of your current flow, they ask you based on the charge divided by the time. Okay, the difference dt, dq with divide by dt. Okay, it's where your q, you need to know how much is this charge, okay, of the electrons, okay, or the current flow, how much is it the charge. After that, you need to take note based on the time. Okay, time always we present or we measure based on the second. Take note, the unit is always should be in the second, unless example during the tutorial message given to you in a minute. Okay, you must convert it into a second. Okay, because this is the one we keep in the unit, international unit. Okay, the symbols. Okay, and the next one is based on the current, how they calculated the current. So it's basically when you have the charge, they provide for you the value of the charge. When they provided for you the time, then we can calculate the current. And why we need to take note the time, why is it important for us to know based on the current flow. Okay, even example when we drive, okay, we need to know. Okay, example from from the KL you're going to Rawang, or from the Rawang you're going to other stated, okay, like Penang, or you're going to the Kedah, Okay, so we always take note based on the time, the durations of the time. Okay, even though is it short time, is it long time? Okay, and also based on the distance, how many, okay, the kilometers. Okay, it's the same time, it's the same thing based on your current flow. We need to take note based on the speed, how the electrons, how speed the electrons move into your circuit. Not into your circuit, it means the flow, okay, in your current. So example, you have source, you have a resistor, you have an inductor, is connected. Okay, so you have the charge. It means the charge is the current flow. So you need to know how much is it the current flow. Okay, take time to complete your one loop. Okay, so in terms of the time, it's very important. Okay, so when you have the current flow into your materials which took too long, then it means it's something wrong with your schematic. Okay, it means the connections, okay, or is something is not proper flow into your schematic based on your diagram. So that's the reason we need to take note based on the time, the durations of the time. Okay, at the same time, okay, this is the one is specific based on your eye, based on your unit. Okay, the measurements unit for this one. Okay, and where they highlighted to you based on the imaginary plane seconds. Okay, 1 ampere. All right. Okay, and I want you to write down, those have your notes with you, just write down this value with you. Sorry, not value, write this equation, the symbol, the formula in your book. Just take note about this part. The current equal to divide by the charge. Uh, okay, just take note based on the formulas that you have here.
Miss,
Yes.
what does the D mean, yeah? dq dt.
Okay, actually that is represent your integration. Actually, they count based on the differences charge with differences time. Okay, but usually we say as Q divided by the T, the equations. Remember, you do
Okay.
some integrations concept, but we're not going to do a maths concept. We just take based on your Q divided by the T.
Okay,
Okay,
thank
but
you.
just take note the formula here, because later on maybe you need to implement or apply the formulas here. Okay, so let's go with the next one here. Okay, the next one, just have a look on the voltage, okay, and how they related based on your work. All right, so work done. Okay, of course we want to move something, okay, from one position to one more position. Of course we need some energy to move the things, right? Okay, it's the same concept with your voltage, and also as we say as a work here. So have a look on energy they requested to move a charge across the conductor. Okay, this where they related to your circuit diagram. Okay, remember, in a real life, okay, example, you have the box, okay, at the middle of your house or something, you need to move your box. So when indirectly when you move the box, you need an energy. Okay, you need some charge to move the box. Okay, the same concept when you implement it into your circuit. Okay, we also have voltage. We say as a voltage, and where we need to have energy. How is it to move? Okay, so in terms of that, okay, just have a look on this the formulas here, how they implemented here. Okay, these equations are okay. Voltage work done of the energy requested. See, work done of the energy requested to move one. See, it means based on the charge. Okay, from one point to other point. Okay, as usual, how you move your things from one point to the next one more point, right? The same thing based on your schematic, based on your circuit diagram here. It's where they're using a terms of the volt. Okay, take note. They also say as a voltage. They also say as a volt. Both are the same. Okay. So in terms of that, they shows you AB. It means based on your schematic. Just have a look on your circuit diagrams here. They have the point of the A which they located or they stated as a positive. At the same time, they have the negative. Okay, it means they stated as a B. And how are you going to calculate it based on your voltage? Okay, so it means you need to take note based on the W. It means the work or energy that you done divided by with your charge, the differences. Okay, at the same time where they stated your W as a work done. Okay, if you remember your work done, usually when it's come to the mass or the way they calculated based on the equations, they're using joule. Okay, it means the symbols of the J. Okay, I think maybe some of you done these calculations before based on the work done. Okay, the unit we measure. Okay, example they say 1000 joule. Okay, you need the mass to move the blocks or to move the components. Okay, the same time. Okay, have a look on the VB. So VB they related to this part here, from this point to this point, and voltage between the point A and B. So it means when you have a voltage, example you assume just we assume, okay, we assume we have a voltage supply, okay, and we have a current flow into a schematic here. So suddenly you have a components here. So when you have a components, we will have a voltage drop, okay, at the components. It means at the resistor we have a voltage drop. So that's the why we always need to take note voltage drop at the components. It means at the elements how much. Okay, example me just let you know. Maybe later on you will understand. We have 5 volt. Okay, example the total supply you have 5 volt, but when you have go through the voltage drop here, you always you need to calculate how much is it voltage drop at this resistance. Okay, indirectly you need to use the Ohm's law. Okay, that's the time you need to use the Ohm's law. Okay, so the way they measure the voltage drop from the terminal A to terminal B, the 2 point here. Okay, okay, the next one is just definitions. Okay, just take note based on this definition. Later on also you may have a look, but just have a look on definition. What they mean with the voltage potential differences with the EMF. Okay, they have a difference here. Okay, so the first one you may have a look since the voltage work done. Okay, to move an electrons from one point to other. Okay, it's also referred as a potential differences. That's the thing is highlighted to you. Voltage they always say as a potential differences, okay, but they try to compare between the 2 points. Okay, when it's come to your EMF, excuse me, okay, what they mean with the EMF. So EMF is the one electron, okay, motive based on the force, they call as EMF. Okay, and how is it works? Okay, it means they're going to have a force is used to move the electrons from one point to other, which is also voltage. Okay, and but EMF they have a different calculation that you need to apply. Okay, but both are how to say both are related to the voltage. Okay, so one is a work done to move the electron, and one more is a work done request for the force. Okay, so that's the thing they call as EMF. Even you can see the word F as a force. Okay, and this everything related to your electrons movement. Okay, but how to say Miss can't shows you. Okay, example I said calculator, I can show you a calculator, but when I say electron, when I say proton, I can't show you because we can't see, but we only can learn based on the theory part. Okay, we need to understand based on the theory part. Okay, that's why we said when I see currents also I only can say as a current, but I can't point out where is it the current. Okay, so that current is come out from the charge. So charge means the atom, okay, the electron atom or the proton atom that we have. Okay, okay, and the next one, okay, let's have a look. This is where we call as a resistant. Okay, take note, resistant represent as a resistor. Okay, sometimes some of the reference book they try to use the word resistant, but the same thing is a resistor too. Okay, and if you realize later on we have the word resistivity. They call as a resistivity. So when they highlighted to you resistivity, or they say resistance, or they say as a resistor, everything the unit that we're going to measure is based on the ohm. Okay, the unit measurements we call as a ohm. So just have a look on this part here. This one, ohm. Okay, the first one they just let you know the flow of the electrons, a current subject. Okay, is the frictions part, and the next one is based on the frictions where they say it as a resistor, represent as a R, which is unit as a ohm. Beside resistor, beside resistor, resistivity, we also have impedance. So all these parameters, the unit that we use is a ohm. This one, okay. And then the third point here is based on the properties of conductor, that limited current. Okay, it's based on the conductor. When I say conductor, can be wire. Okay, they also can say based on your component, conductor components. Okay. Okay. All right. Okay. Now, since we have nearly 10 minutes, okay, I just want to get some feedback from you when you see the image at the slides. Okay. Before that, I just like they give you some information, okay, where they specific for you. 1 ohm is defined as a resistance which is have a current of 1 ampere. Okay, falling through it when it's 1 volt is applied across it. Okay, this the one they shows you in terms of the tag is just a theory part. They just inform to you. It means when they have 1 ohm of the resistance, you have the current flow of 1 ampere, and where you supplied the voltage is 1 ampere. This is just a theory part. Sometimes you can have a 50 resistance where you have the currents in terms 3 milliampere where you have the supply in terms of a 2.5 volt. So the one that's specific in your slide is just a theory part. Okay, they're just specific for you. So when you have a look on the calculations part, okay, based on the equations here, based on the resistance, they shows you potential differences divided by the current. Actually, these equations are represent based on the Ohm's law. Okay, means just specific for you one up. Okay, you can use the triangle shape to identify. It's up to you. Okay, V with the IR, and this one we call as a Ohm's law. Okay, can say as a method, we can say as a technique, but most of the common things we say as a law. Okay, the equation that we apply for to calculate. Okay, so when you see the voltage, when you see the current, I always stand for current. Okay, R always stand for your resistance or resistivity, or we call as a resistor. And the V stand for your voltage. Okay, and voltage which represent the potential differences. Okay, from here, from this equation or from this triangle, when they ask you to calculate for the resistor, okay, I just wrote here as resistance. Okay, you need to know voltage divided by the current. It means potential differences divided by the current. Unless they ask you to find for your voltage value. Okay, how much is it your voltage value? So you need to know the current divided by the R. Okay, it means this is the equation that you need to get. Example, I asked you to find the value of a current. Example, how much is the current? So current, ampere, it means voltage divided by the resistance. Okay, this is the basic equation that you need to know. Okay, later Miss will share you a formula in a OneNote. Okay, and based on this diagram, just have a look on this diagram. Okay, in this diagram, you can see a person here. Okay, the road has ohm. The second one, you can see the second person here. Okay, quite in the face, like angry face here. Okay, which is defined as a volt. And the same time, you can see the ampere. Okay, it's like a struggling to move. Okay, from the like a hole, you can see like a part here. Okay, and where it's tied up. Okay, by the ohm. Okay, from this image, let me erase first. Okay, from this part, from this image, okay, anyone can let me know what you understand based on the diagrams here. Anyone based on the diagram. It's okay. You just let me know based on your understanding when you see the image here.
The resistance will reduce the current. I mean, will reduce the voltage, so the current will be smaller.
Current will be smaller. Okay, that's your one. That's you understand from the image, yeah?
Can I go?
Yes, yes, yes.
Okay, so as the resistance is high,
Okay,
then the current will be low, and the voltage will be high also.
voltage will be high. Okay. Other than that, okay, some or two of your friends already give me the answer, but anyone else can let me know in a different way, a different way.
I think I think ma'am they're inversely proportional to each other, resistance and current.
Okay, what is it?
Inversely proportional.
Inverse.
Yes,
Explain
ma'am.
again. Okay, I think some of your friends said based on inverse, I think the word. Okay, anyone else?
Miss, can I ask about something else?
Something else. Okay, what is it?
I just wanted to ask, is this supposed to be our chapter 1, or because I noticed in the slides, right, chapter 5 for this?
Yes, this is chapter 5. That's why
Okay.
Miss said, Miss not go follow based on the sequence.
Oh,
The thing is,
okay.
uh,
So what about
don't worry.
the exam and class test and all, like, would it
What is it?
be things like exam and class test, right? You will tell us which chapter it is lah.
Yes, yes. Don't worry us. I will let you know. Okay. Miss will inform you. When we have a quizzes, Miss will inform you. Okay, we have these quizzes on this chapter. So the second quiz we have based on this chapter. Even your final exam, which topic will be covered up? Okay, as Miss informed earlier, Miss not go on with the sequence because some topics you need to know earlier before we go with the next topic. So that's the reason Miss come up with the chapter 5 first before we go on with the next topic. Some understanding.
Yeah,
Okay.
okay, got it, Miss.
Okay. Anyone, any try based on your diagrams here?
Miss, can I try?
Yes, yes, of course.
I
Go
think
on.
as the ohms increase, and then as the ohms increase, right, and then I think the voltage as it also increase is trying to push the amperes across the whole. I think it's like that.
Okay. So what happened to your ampere? Is it this increase? Is it reduced?
As in the diagram, I think is decreasing because you want to fit through the hole more, I think.
Okay. All right. Okay. Thank you. I'm not sure who's the person, but thank you for the answer. Okay. Anyway, that's a good try. Okay. Maybe some of you maybe can try other questions later on. Okay. So the one you can see. Okay. They already give you some clue. Okay. When you have the ohm, it means you already have some a resistor. So when you have the resistor, indirectly you're going to have a current flow into your resistance. So it means you're going to reduce your we call this increase your currents. Okay, you will happen a this increased current when you have a resistance. Unless you just think when you don't have any resistor, this man is not here. Example is not here. So based on your voltage or based on your current flow will be very smooth. Okay, so only thing will be affected when you have a resistor. That's why they say the word resistor as a load. Okay, so that's a good try. Those give me the answer. I think Muhammad Saad give me the answer. Innovations professionals. Okay, all right. So thanks for your answer. That's a good try. Okay, let's go with the next one is based on the passive element. Okay, this passive element we will cover up on the topic resistor topic. We have capacitor topic. We have the inductor topic. Okay. Okay, so Miss just want to show you. Okay, this is based on the source. Okay, right. Okay, now mind. Just have a look on this one. Okay, take note. This part Miss will cover up based on the topic because in the resistor we have their own topic. Okay, they stand alone. Okay, they have their own chapter. Resistor they have their own chapter. Same goes to inductor. They have their own chapter. Okay, so this one will be cover up based on the chapter. Okay. So just this part you just have a look. They say this component as a passive element. Okay. So have a look on the next part slides here based on the circuit elements here. Okay. So this is based on the source, how they defined it, the source. Okay, how they say is a current source, how they say is a voltage source. And at the same time, we also have independent source. We also as a dependent source. Okay, how they represented the source, how they specific the source. So usually you may find out based on this part here, on this slide, circuit element. Okay, so example, they say independent. So when they say independence, based on your source, they always shows you polarity positive with a negative. It means you need to know that's represent based on your voltage. Unless they shows you in terms of the error going up or going down. Okay, not necessarily they always shows you error going up. They also can shows you error going down. So when you have this symbol, okay, the circle, then it shows you error. This represent for your current. So remember that. So when you have based on the circle, we always say as independent. Once they shows you in terms of diamond, Miss call here as a diamond. Okay, you can see the shapes here. Okay, so this shape, okay, this will be specific as an independent. Okay, so that's the one you need to highlight it when the polarity positive negative means the error. So when you have a schematic later on, a circuit diagram, you need to identify the source is a current source or is it a voltage source. So usually minus negative is a voltage source. When it shows you in terms of the error, there is a positive current source. Okay, so that's the one you need to take note on this part here. Okay, the next one, okay, Miss will skip based on the introductions, based on the history. Okay, who the one like a scientist found the formulas of the Ohm's law. This is the one Miss mentioned just now based on the Ohm's law. The equations that you need to know based on the calculations. Okay, So later on, you may have a look on this part, history, okay? I just want to go on with, okay, so just have a look on these equations. Maybe I drag some more 5 minutes, okay? So in terms of your Ohm's law here, they applied it based on the voltage, okay, where they're using the inversions proportionals for your resistance. This is the one your friends give me the answer just now, okay, based on your formula equation. This is the one, okay, how is it works, all right? At the same time, when you do calculations for your electronic calculations or even for your electrical, okay, sometimes you need to calculate based on the power calculations, okay, we also can implement the equations too, okay. So this is a formulas that you need to take note, okay. You may write down this equation. These equations we call as Ohm's law, okay. I'm just not going to repeat back, okay. V stand for voltage, R stand for your resistor or resistance, and I stand for the current. It means current, the flow, okay, the current flow, okay. Okay, this is a one of the part based on the electrical power energy. Okay, just take note based on the equations here, because later on I'm going to share you the formula with you. Just take note based on the equations power, how they calculated. So in this part, they just specific for you electrical power based on the energy. So in terms of here, this equation, to define a power, okay, you need to know the work of you done, okay, like energy. So it means it's a joule, how you calculate. And the next one, they defined it based on the time. It's the same way how you defined it for your current. If you remember the current, how you define based on the charge, Q over T. It's the same concept when it's come to the power equations. Okay, just jot down, just write down based on the equations. Okay, all right, okay. From this part, Miss will show you the formula. Okay, how we get the equation, even though we have a V equal to voltage I, and we also can represent a different formulas here. So this one Miss will explain in one note here, okay. That's the one. Just take note about this part here. Okay, based on the joule, how they converted based on the joule, 1 joule equal to 1. Okay, and at the same time, power calculations, we use the unit of the watt. This one. Okay, right now, okay, before we go on with the next section, we take a break for a while, but I just want to specific for you one thing here. Okay, just behold, okay, the next one is just your some of the calculations, okay, is a Q&A section, okay, but means not go on with this one because this will be catch up in your tutorial sections later on. Okay, so I want to share with you one note. Okay, let me stop recording here first. Okay, and some of you are having issues. Okay, I hope you are settled.